Okay, so this is an interaction of a current carrying conductor through in a magnetic field. Okay, so remember a current carrying conductor in its own right has a magnetic field around it. Okay, so if you remember that. Now, when you interact that with another magnetic field, there'll be a force because it's two magnets essentially coming close to each other. Now, so if we had two magnets, this will look like this, and a magnetic field between them, going from north to south, and then through all that you then have a wire, and this wire is carrying current I. Now what you use is your left hand Fleming's rule. So you got force, magnetic field, current, so FBI. You align them so that everything's 90 degrees, so your force to magnetic field 90 degrees, magnetic field to current is 90 degrees, force to current is 90 degrees, it's all 90 degrees to each other. You can then find out the direction of the force. Now in this case, the wire must be feeling a force in which direction? It'll be feeling a force in the down direction. So what you can do is you can go to Google Images to find a good image. This one is in Google Images. It's a good one to use. Now if we look at a case where we've got a magnetic field going into the page, and we had our conductor going across this way, and there was a current I, then you can do the same sort of thing. So B is into the page, I is to the right, and that means the force is going to be up this way. Now what is the size of the force? It's given by this equation, BIL, okay, where that's the force in newtons. This is the magnetic flux density, in other words the magnetic field strength, and that is measured in Tesla. I, that's current, obviously in amps, and L, that is your length inside the magnetic flux density or field strength, or the magnetic field. And that's obviously measured in meters. So that gives you the force. Now, that equation really only works where you have your magnetic field and your wire is 90 degrees to it. However, if your wire was off at an angle, okay, no longer 90 degrees, so you've got an angle there, instead of it being 90, then you can use F equals BIL sine theta, where 90 degrees gives you the maximum force. Anything other than that, you have to take the component which reduces it. Now the last thing is, what is the Tesla? Just think about what it means. You sort of rearrange that formula. So you rearrange that formula, and effectively it's when you have 1 Newton, 1 amp, and 1 meter all at 90 degrees. You just write that in a sentence.